Hello guys, Cristiano here. I am a C programmer, learning all those things that I can. Hit the subscribe button, let a comment, that'll help so much the channel. All my videos, you'll be in a fast mode with explanation. I'll reduce the time to be more precise. And we will face a lot of mistakes and debugs. Everything's calculated, or not. So don't be afraid. The link for all the source codes will be in the description. If you wanna follow, just get your copy. During implementation, I encountered issues with handling requests that, during processing, store data in the database, leading to loss of records. To solve this problem, I utilized the concept of a worker. It was perfect since I already had the QE data structure implemented. By combining it with a thread pool, I can make the processing asynchronous. In this video, we will add this feature to SAT, which I named it such worker. We start by creating a header and adding it to set.h because it's a built-in resource, and then created the source file. We created a test file. We added the site work to the installation. We already added the site work source file to site source list. Start an implementation. We include some headers and create a handler to process users' data. We created its context, which contains a mutex, a conditional variable that works together with a mutex, a list of threads, a number of threads to be allocated, the QE data structure, the size of user's object, and the handler that will be used to process the queue. Next, we create the arguments where we configure the number of threads, the size of the user's object, and the handler. We create 4 functions, some of which are already familiar to us. We attach to the feed function. This function will feed the QE through an object reference. We copy and paste into the source file. We include some headers and paste the functions. Now it's boilerplate. In the init function, we clear the context. In the open function, we test the args. If it is not new, we proceed. We use a do while loop to configure it. We test the arguments with the isArgsValid function. Its implementation is simple. We check if the object size is greater than 0, if the pool size is greater than 0, and if the handler has been implemented. Next, we assign values to the context. We then create the QE using the object size. Next, we call the threads allocation function to allocate the threads. We allocated threads based on pool amount, checking if the allocation was successful. Continue the configuration. We start the threads with thread starts. In the implementation, we use a for loop to start each thread. If it fails, we return an error. For creation, we need a handler that we call thread function, which we will implement later. In the feed function, we check if the data is valid, we lock the context with mutex lock and add the object to the queue. We signal that there is a new data with a con signal and release the mutex with unlock. In the close function, we check if the queue was initialized. If so, we release the resource. And the same goes for the list of threads. Now the implementation of threaded function. We retrieve the context through casting and create a stats variable. We allocate a buffer to the side of the user object to copy the object to the list. This could be put into the context. Inside a while true loop, we lock the context with mutex. We clear the buffer before getting an object from the queue. If it is null, we wait for the signal or notification and try to get the object again. If it's successful, we pass it to the user's handler for processing and unlock the mutex. Exiting the loop, we use to clear the buffer allocated for the object and we return null. Moving to the test, we include the headers. We create our beloved person object. We create a handler. We declare a stats variable in a vector of persons with two objects. We declare the worker instance and create the arguments, passing the handler, the object size, and the number of threads. We initialize the instance with init and configure it with open. We implement a for loop with 200 iterations to feed the queue. We wait a second for the queue to be processed and close the instance. We implement the handler that will get the object by casting and print it. We create a test rule in its build script. We clean the build and recompile. We get an undefined reference error. We didn't link with the pthread library, which is now part of the lib. We can remove it on other occasions. And include the error. We missed the stdio, compile and run the test. Everything's fine. We will remove the pthread linkage. Test one last time. And everything's fine. This feature emerged from the challenge that I faced during the implementation. It's very important to have these moments as related to the creation of a resource for future use. That's all for now. I appreciate it if you get here. Don't you forget to hit the subscribe button, leave a comment and share. Knowledge is not enough. Waiting for more. Bye. See you soon.